morning. Welcome to the Let Us Crack Gate ME. This is K. Umamaheshwara Rao. Unacademy is offering early bird offer, flat 50% off. Join the Ummeed and Sangram batch for GATE ESE 2025 and 26. Batches starts from 9th February. Flat 50% off. Join Ummeed and Sangram batch. Unacademy is announcing Ummeed batch for GATE, ESE, PSUs 2025. Batch commences from February 9th. Unacademy is announcing Sangram batch for GATE, ESE, PSUs 2026. Batch commences from February 9th. Good morning, Hardik. Good morning. Good morning, everyone. Unacademy is announcing Ummeed batch for GATE Data Science and Artificial Intelligence for 2025. Batch commences from February 9th. Unacademy is congratulating GATE 2023 top rankers and Unacademy is congratulating ESE 2023 top rankers. Today I would like to discuss PYQs of Engineering Mathematics for XE from 2008 to till now, till 2023 GATE. Okay? Now. Good morning, Akshat. Let A and B two similar square matrices of order 2. 1 and minus 2 are eigenvalues of A. Then trace of B. Then trace of B. Here they have given one hint. What is the hint? A and B are similar matrices. A and B are similar matrices. If A and B are similar, eigenvalues of A and B are same. Given that A and B are similar matrices, therefore eigenvalues of, voice is low, just a minute. Hello. Hello. Now. Hardik. Am I audible? Hardik, am I audible? All okay? Right. Given that A and B are similar, therefore eigenvalues of A and eigenvalues of B are same. Eigenvalues of A and eigenvalues of B are same. Now, trace of B equal to sum of eigenvalues of B. Eigenvalues of A and B are same. Therefore, minus 2 plus 1. Therefore, minus 1. Answer is minus 1. Understood? Next problem. Let the eigenvalues of matrix A are 1 and 2. The corresponding eigenvectors are provided. We have to find out the element A22. Understood? So whenever eigenvalues and eigenvectors are given, the best method is Ax equal to lambda x. Now, let us take the 2 cross 2 matrix. A is ABCD. First eigenvector 0.6, 0.8. Lambda 1 is 1. 0.6, 0.8. Understood? That is 0.6a, 0.8b equal to 0.6. Okay na? Now ABCD multiplied with 0.8 and minus 0.6 equal to lambda 2 is 2, 0.8 minus 0.6. Now observe 0.8a minus 0.6b equal to 2 into 0.8 means 1.6. 0.6c plus 0.8d equal to 0.8. 0.8c minus 0.6d equal to minus 1.2. Understood? By solving these two. Good morning, Mayank. Good morning, everyone. By solving these two, we get the value of A is 1.64. The value of B is minus 0.48. By solving these two, the value of C is minus 0.48. Minus 0.48. The value of D is 1.36. Therefore, matrix A is 1.64 minus 0.48 and minus 0.48 and 1.36. The value of A22 is 1.36. That is the answer. Understood? Observe this problem. Matrix P is 1 1 1 1, a 2 cross 2 matrix. We have to find out p power 8 minus 2, p power 7 and so on. It is a problem designed on Calle-Melton theorem. First to calculate characteristic equation. Determinant of p minus lambda equal to 0. One minus lambda whole square minus 1 equal to 0. 1 minus 2 lambda plus lambda square minus 1 equal to 0. Lambda square minus 2 lambda equal to 0. Call it equation 1. By Cayley-Hamilton theorem, p square minus 2p equal to 0. Call it equation 2. Next, p power 8 minus 2p power 7 plus 2p power 6 minus 4p power 5, 3p power 4 minus 6p cube plus 2p square. Now let us take p power 6 common, p square minus 2p. Here let us take 2p power 4 common. In these two terms, p square minus 2p plus here let us take 3p square common, p square minus 2p plus 2p square. From equation 2 we have p square minus 2p is 0. That's why this term is 0, this term is 0, this term is also 0, plus 2. P square is nothing but p square minus 2p. 0 means p square equal to 2p na? That's why 2p. 2 into 2p is 4p. Finally, the answer is 4p. Understand? Which one of the following matrices have same eigenvalues? Same eigenvalues. Just by observation you can able to solve. Which of the following matrices have same eigenvalues? Observe. Second option is correct. Understood? Because leading diagonal elements are 1 and 3. Here also leading diagonal elements are 1 and 3. 2, 4, 4, 2. That's why you will get same eigenvalues in the case of option B. Next problem. The eigenvalues of 3 cross 3 matrix P are 2, 2 and minus 1. 2, 2 and minus 1. Then P inverse is equals to. Then what is P inverse? Observe. The eigenvalues of 3 cross 3 matrix are provided. Therefore, first you have to calculate characteristic equation. Lambda minus 2 into lambda minus 2 into lambda plus 1 equal to 0. Lambda square minus 4 lambda plus 4 into lambda plus 1 equal to 0. Okay na? That is lambda cube plus lambda square minus 4 lambda square minus 4 lambda plus 4 lambda plus 4 equal to 0. Minus 4 lambda plus 4 lambda cancel. Lambda cube plus lambda square minus 4 lambda square minus 3 lambda square plus 4 equal to 0. Lambda cube minus 3 lambda square plus 4 equal to 0. Called it equation 1. by Calamondon theorem, PQ minus 3p square plus 4i equal to 0. Called it equation 2. 4i equal to 3p square minus p cube. Okay na? You require p inverse na? That's why multiply with p inverse on both sides. 4i p inverse equal to 3p square into p inverse minus p cube into p inverse. 4p inverse is 3p minus p square. Therefore, p inverse is 1 by 4 of 3p minus p square. 1 by 4 of 3p minus p square. Next problem. For any positive numbers A and B, the matrix 1AB 4, 5, 6. 1AB multiplied with 4, 5, 6. This is a 3 cross 1 matrix. This is 1 cross 3 matrix. 3 cross 1 with 1 cross 3. 3 cross 1 with 1 cross 3. Result is 3 cross 3. So for that 3 cross 3 matrix, we have to analyze whether the matrix is orthogonal or diagonalizable or non-singular or of rank 2. Okay. Now matrix P is 1 multiplied with 4, 5, 6. You'll get 4, 5, 6. 4a, 5a, 6a. 4b, 5b, 6b. Understood? Now, what is rank of this matrix? Rank is 1. Because all the rows are proportional, therefore rank is 1. They have given rank 2. That's why this option is incorrect. If rank of the matrix is 1, matrix is 3 cross 3, then determinant value 0. Therefore, it is not non-singular. Non-singular is incorrect. Anyhow, it is not orthogonal. Why it is not orthogonal? Here determinant value 0. Determinant value of P equal to 0 because rows are proportional. Generally, for an orthogonal matrix, determinant value is always either 1 or minus 1. That's why it is not orthogonal. So, what is left? Only diagonalizable is left. So, diagonalizable is correct. Otherwise, you can calculate in this manner. Here, 3 rows are proportional, therefore compulsory 2 of the eigenvalues are 0. Third eigenvalue 4 plus 5a plus 6b. It is a non-zero eigenvalue. It is non-zero eigenvalue. For this non-zero eigenvalue, there exists one non-zero eigenvector. What about for eigenvalue 0? In the case of eigenvalue 0, geometric multiplicity is given by total number of variables 3 minus rank of p minus lambda I. Lambda is 0, that's why p minus 0i. 3 minus rank of p. Rank of p is 1, that's why 3 minus 1 is 2. Geometric multiplicity is 2. So here geometric multiplicity 2 means 2 independent eigenvectors in the case of eigenvalue 0. 1 independent eigenvector in the case of 4 plus 5a plus 6b. There are 3 independent eigenvectors, 3 eigenvalues. Algebraic multiplicity and geometric multiplicity of each eigenvalue is same. Therefore, the matrix is diagonalizable. That's why diagonalizable is the correct option in this problem. Next problem. Next problem. the matrix 1 4 5 0 2 6 0 0 3, consider the following statements. 3 is an eigenvalue of M. 410 is an eigenvector of M. 420 is an eigenvector of M. Which of the above statement is true? Observe. When you look at leading diagonal elements, clearly we can understand that 1, 2, 3 are eigenvalues. So 3 is an eigenvalue of M is true. Because matrix is triangular. Eigenvalues of triangular matrix are its leading diagonal elements. Therefore, 1, 2, 3 are eigenvalues of matrix M. Therefore, 3 is one of the eigenvalue. Yeah, P is true. Now, what about Q? I am examining Q by using Ax equal to lambda x logic. Mx. One, 4, 5. 0, 2, 6, 0, 0, 3. 1 into 4, 4. 4 into 1, 4. 5 into 0, 0. 0 into 4, 0. 2 into 1, 2. 6 into 0, 0. 0 into 4, 0. 0 into 1, 0. 3 into 0, 0. That implies 8, 2, 0. That is 2 times of 410. 2 times of 410. That is 2x. Mx equal to 2x. Therefore, clearly 410 is an eigenvector of M. That is also true. Sir, what about 420? Multiply. Similar manner. 145,026 003 multiplied with 420. 1 into 4, 4 plus 4 to ja 8. 5 into 0, 0. 0 into 4, 0. 2 into 2, 4. 6 into 0, 0. 0 into 4, 0. 0 into 2, 0. 3 into 0, 0. That is 4 plus 8, 12. 4, 0. It is not equal to either 1x or 2x or 3x. That's why it is not possible to write lambda x form. Okay? Because if you take 4 common, you will get 4 into 3, 1, 0. That is not an eigenvector. That's why 420 is not an eigenvector. This is false. So P and Q are true but not R is the correct option. Understood? Next problem. For the matrix M 1 0 minus 1 0 1 minus 1 1 1 minus 2, consider the following statements. First you have to find a characteristic equation. 1 minus lambda 0 minus 1. 0 1 minus lambda minus 1. 0 1 minus lambda minus 1. 1 1 minus 2 minus lambda equal to 0. Understood? That implies one minus lambda of minus 2 minus lambda plus 2 lambda plus lambda square minus 2 minus lambda plus 2 lambda plus lambda square plus 1 minus 1 of 0 minus of 1 minus lambda equal to 0. If you take 1 minus lambda common, lambda square plus lambda minus 1 plus 1 equal to 0. That is minus 1 plus 1 cancel. 1 minus lambda into lambda square plus lambda. One minus lambda into lambda square plus lambda equal to 0. Plus lambda square minus lambda square cancel. Lambda minus lambda cube equal to 0. Lambda of 1 minus lambda square equal to 0. Lambda equal to 0, lambda equal to 1, lambda equal to minus 1. So 0, 1, minus 1, 0, 1, minus 1 are eigenvalues of matrix M. Three different eigenvalues. Whenever you have three different eigenvalues, definitely you will have three different independent eigenvectors. Whenever you have three different eigenvalues, you will have three different independent eigenvectors. Understood? Therefore, it is diagonalizable. Matrix is diagonalizable and determinant value of M equal to 0 because one of the eigenvalue 0. Therefore, M inverse does not exist. M inverse does not exist. Therefore, M is diagonalizable is true. M inverse does not exist is true. Lambda cube minus lambda equal to 0 is the characteristic equation is true. All three are true. P, Q, R are true. Understood? Next problem. 1, 0, minus 1. 1, 0, minus 1 are eigenvalues of a 3 cross 3 matrix A. Then the trace of A square plus 5A is eigenvalues of A are 1, 0, minus 1. Therefore, eigenvalues of A square 1, 0, 1. Eigenvalues of 5A 5, 0, minus 5. Therefore, eigenvalues of A square plus 5A 1 plus 5, 6. 0 plus 0, 0. 1 minus 5 minus 4. Now, the trace of A square plus 5A is 6 plus 0 minus 4. Final answer is 2. Now the trace is 2. Understood? Yeah, trace is 2. Next problem. R and S be the real numbers. A is 120, 203, R S 0 and B is 11 S minus 1. Then Ax equal to B has. It is a non-homogeneous system. That's why first you have to consider augmented matrix AB. Augmented matrix AB 120 120 203 RS0 11 S minus 1. Apply the operations. R2 minus 2 times of R1. R3 minus R times of R1. One two zero. Two minus two zero. 0 minus 4. 3 minus 0 is 3. 1 minus 2 is 1 minus 2 is minus 1. Now R3 minus R times of R1. R minus R0. S minus 2R. 0 minus 0 0. Here S minus 1 minus R. Now for different conditions you'll get different types of solutions. Now suppose, three options are in terms of S equal to 2R, one option is S not equal to 2R. Suppose S not equal to 2R, what happened? First case, if S is not equal to 2R, then rank of A equal to rank of AB equal to number of variables. Unique solution will come. If S is not equal to 2R, then you will get unique solution. So first option is incorrect. Suppose if S equal to 2R, what happens? Suppose if S equal to 2R, then what happens? Rank of A become 2. Rank of AB is depending on S value and R value. S equal to 2R not equal to 2 gives you rank of A and rank of AB must be equal when S value equal to 2R equal to 2. If S equal to 2R equal to 2, then rank of A will be 2, rank of AB will be 2, number of variables are 3, then you will get infinitely many solutions. So if all three are S equal to 2R equal to 2, then what happened? You will get last row becomes 0 row. Then you will get infinitely many solutions. Unique solution if S equal to 2R equal to 2 is wrong. S equal to 2R not equal to 2 infinitely many solution is incorrect. Only last option is correct. Understood? Next. 0 minus 1 2 1 0 3 and minus 2 minus 3 0. Which of the following statement is incorrect? Which of the following statement is incorrect? First we have to calculate eigenvalues of the matrix. Look at the matrix once again, you will get one idea. All the leading diagonal elements are 0. Here minus 1, here 1, 2, minus 2, 3, minus 3. What is speciality of this matrix? It is a skew symmetric matrix of odd order. It is. Skew symmetric matrix of odd order. If A is a skew symmetric matrix of odd order, determinant A equal to 0, that is one point. Another point, eigenvalues are either 0 or purely imaginary. Eigenvalues are either 0 or purely imaginary. See, one of its eigenvalue 0, true. Purely imaginary, true. It has non-zero real eigenvalues, incorrect statement. In this problem, you have to find out incorrect statement only. Incorrect one only. Sum of eigenvalues 0, that is also true. Which one is incorrect? Third option is incorrect. So correct answer is third option. Next problem. Matrix M is 1 1 0 1. Which of the following is correct? 1 1 0 1. First you calculate eigenvalues. Lambda equal to 1 comma 1. Algebraic multiplicity of eigenvalue 1 is 2. For eigenvalue 1, algebraic multiplicity is 2. Corresponding to lambda equal to 1. Consider m minus 1i of x equal to 0. Put lambda equal to 1, 0, 1, 0, 0. Now, rank is 1. Number of variables 2. So, free variables. Two minus 1. Geometric multiplicity is 1. See, algebraic multiplicity is 2, geometric multiplicity is 1. Therefore, it is not diagonalizable. Therefore, M is not diagonalizable. So, correct answer is matrix is not diagonalizable. So, diagonalizable is wrong. So, answer is either A or C. Observe, rank of M is 1. Actually rank of M is not 1, rank of M is 2. 1 is the only real eigenvalue and M is not diagonalizable is the correct option. Mayank, rank of M is not 1. Rank of M minus lambda I is 1. Rank of M minus lambda I is 1. Okay na? This one, rank of M minus lambda I. Whose rank is 1? Not rank of M is 1. Okay na? Third option is correct. The condition for diagonalizable is algebraic multiplicity and geometric multiplicity of each eigenvalue must be same. Algebraic multiplicity and geometric multiplicity of each eigenvalue must be same. Then only the matrix is diagonalizable. Next problem. Consider the system of equations 2x2 plus x3 equal to 0, minus 2x1 minus x3 equal to 0, minus x1 plus x2 equal to 1. So first consider augmented matrix AB. Minus 1, 1, 0, 1. Minus 2, 0. Minus 1, 0. 0, 2, 1, 0. Okay na? First you have to apply elementary operations. R2 minus 2 times of R1. Yeah, minus 2 plus 2, 0. 0, 0, minus 2 is minus 2. Next, minus 1, minus 0, minus 1. 0, minus 2, minus 2. Next. Zero, 2, 1, 0. 0, 2, 1, 0. Next. R3 plus R2. Minus 1, 1, 0, 1. 0, minus 2, minus 1. Minus 2. 0 plus 0, 0. 2 minus 2, 0. 1 minus 1, 0. 0 minus 2 is minus 2. Here rank of A is 2, but rank of AB 3. Both are not equal. Therefore no solution will come. Answer is no solution. Correct answer is no solution. Next problem. Matrix A is 5 minus 3 is 6 minus 4. Then trace of A power 1000. First you have to calculate eigenvalues of A. Characteristic equation is a minus lambda equal to 0, 5 minus lambda minus 3 6 minus 4 minus lambda minus 20 minus 5 lambda minus 20 minus 5 lambda plus 4 lambda plus lambda square plus 18 equal to 0. Lambda square minus lambda minus 2 equal to 0. Called it equation 1. From this you can write, your job is to calculate eigenvalues. Lambda equal to 2 comma minus 1. Understood? Lambda equal to 2 comma minus 1. Therefore eigenvalues of A are 2 comma minus 1. Eigenvalues of A power 1000, 2 power 1000 minus 1 power 1000. 2 power 1000 is 2 power 1000 minus 1 power 1000 is 1. Therefore trace of A power 1000 is 2 power 1000 plus 1. So trace of A power 1000 is 2 power 1000 plus 1. Second option is correct. Understood? Next problem. This is lambda cube. The characteristic equation of lambda cube, a 3 cross 3 matrix is lambda cube minus lambda square minus lambda cube minus lambda square plus lambda minus 1. Then the matrix should be, please observe, the characteristic equation is if you take lambda square common, lambda minus 1. If you take lambda minus 1 common, lambda square plus 1. Lambda minus 1 equal to 0, therefore lambda equal to 1. Lambda square plus 1 equal to 0, lambda equal to plus or minus I. Therefore the eigenvalues are 1i minus I. 1i minus I. Understood? 1i minus I. Dvivedi, yesterday I took one special class on sequence and series, which is extra syllabus of XE. Okay na? I will provide you the link now. Yeah, on Unacademy Learning app only. This is the link. Yes, XC questions are tougher than mechanical questions. It is true. Abhay Singh, condition for diagonalization is algebraic multiplicity and geometric multiplicity of each eigenvalue must be same. Algebraic multiplicity and geometric multiplicity of each eigenvalue must be same. Dvivedi, I have sent you the link just now. You verify. Right. Next, come to the problem. We have to solve the system of equations by LU decomposition method. LU decomposition method. After that, we have to find out the values of U23 and L32. Actually, it is not L23, L32. Okay, L23, U23 and L33, L33. Our job is to calculate U23 and L33. Mayank, you verify this link. Sequence series for XC Brahmastra. Got it? Now, solving system of equations. First you write the matrix. A is 401, 1, 2, 3, and 0, minus 1, minus 4. 0, minus 1, minus 4. That is matrix A. Got it? Now, matrix A can be written as product of a lower triangular and upper triangular matrix. A is equal to LU. Four zero one two three. Now 1 U12 U13 01 U23 001 L1100 L21 L220 L31 L32 L33. 0 1, 1 2 3, and 0 minus 1 minus 4. Multiply row with column. L11, first row with second column, L11 U12, first row with third column, L11 U13, second row with first column, L21, here you will get L31, here L21 U12 plus L22, next L21 U13 plus L22 U23, second row with third column, L21 U13 plus L22 U23, third row first column is over, third row second column, L31 U12 plus L32, next third row with third column, L31 U13 L32 U23 plus L33. Equate corresponding elements on both sides. You will get L11 is 4, L21 is 1, L31 is 0. Next L11 U12 equal to 0. Therefore U12 equal to 0. 4 into U12 equal to 0. Finally U12 equal to 0. Next L11 U13 equal to 1. 4 into U13 equal to 1. U13 is 1 by 4. U13 is 1 by 4. L21 U12. L21 U12 plus L22 equal to 2. L21 is 1. U12 is 0. Plus L22 equal to 2. Therefore L22 equal to 2. Next L21 U13 plus L22 U23 L22 U23 equal to 3. L21 is 1. U13 is 1 by 4. L22 is 2 into U23 equal to 3. Now 2 into U23 equal to 3 minus 1 by 4. 4 3 is 12. 12 minus 1 11. 11 by 4. U23 is 11 by 8. U23 is 11 by 8. 11 by 8 means 1.375. U23 is 1.375. 1.375 is in two options. Therefore, second option is incorrect, fourth option is incorrect. Now our job is to calculate L33. Next we have to equate L31 U12 plus L32 equal to minus 1. L31 is 0. So this term is 0. Therefore, L32 equal to minus 1. Last one. L31 U13 plus L32 U23 plus L33 equal to minus 4. Equal to minus 4. Here L31 is 0, that's why this term 0. L32 is minus 1. U23 is 1.375 plus L33 is unknown, equal to minus 4. Therefore, L33 equal to minus 4 plus 1.375. Therefore, L33 is minus 2.625. Minus 2.625. That's why third option is correct. First option is incorrect. Understood? Right. Next problem. The value of alpha for which the system of equations x minus y minus 3z equal to 3, 2x plus z equal to 0 and minus 2y minus 7z equal to alpha. First you have to consider augmented matrix. First you have to consider augmented matrix AB. One minus 1 minus 3 3 2 0 1 0 2 0 1 0 1 minus 1 minus 3 3 2 0 1 0 0 minus 2 minus 7 alpha. Apply the operation R2 minus 2 times of R1 1 minus 1 minus 3 3. Operation is in second row. 2 minus 2 0 0 minus 2 into minus 1, that is plus 2, and 1 plus 6 7. Next 0 minus 6 minus 6 0 minus 2 minus 7 alpha. Do one thing, add third row and second row. By adding R3 and R2 we get 1 minus 1 minus 3 3 027 minus 6 000 alpha minus 6. In this problem, has a solution means compulsory alpha minus 6 must be 0. Alpha value must be 6. If alpha equal to 6, then only rank of A equal to rank of AB equal to 2, number of variables 3, infinitely many solution will come. It possesses a solution only when alpha equal to 6. Observe next problem. Matrix Q is 3 to 4, 2, 0, 2, 4 to 3, and P is V1, V2, V3. That is a model matrix. Then the sum of absolute values of all the elements of P inverse QP. P inverse QP is nothing but diagonal matrix D. It is a problem designed on diagonalization only. P inverse QP is nothing but diagonal matrix D. In the diagonal matrix, you are going to get eigenvalues as leading diagonal elements. Our job is to calculate modulus of lambda 1 plus modulus of lambda 2 plus modulus of lambda 3 is what? Okay, na? So our job is to calculate first eigenvalues. Write characteristic equation. Determinant of P minus lambda equal to 0. 3 minus lambda 2, 4. 2, 0 minus lambda 2, 4, 2, 3 minus lambda. Minus 3 lambda plus lambda square minus 4. Minus 2 of 6 minus 2 lambda minus 8 plus 4 of 4 plus 4 lambda equal to 0. Understood? Q minus lambda. Yes. Our original matrix is Q, na? Right. Come to the point. If you simplify this, you'll get finally minus 9 lambda plus 3 lambda square minus 12 plus 3 lambda square minus lambda cube plus 4 lambda plus 4 lambda, then 6 into 6 minus 8 is minus 2 into minus 2, that is plus 4 lambda plus 16 lambda equal to 0. By simplifying this, we get minus lambda cube plus 6 lambda square plus 15 lambda plus 8 equal to 0. Lambda cube minus 6 lambda square minus 15 lambda minus 8 equal to 0. Therefore, lambda equal to 8 comma minus 1 comma minus 1. Lambda 1 is 8. Lambda 2 is minus 1. Lambda 3 is minus 1. Therefore, the sum of absolute eigenvalues equal to 8 plus 1 plus 1. That is 10. Therefore, final answer is 10. Therefore, final answer is 10. Understood? Next. Let A be a 4 cross 3 non-zero matrix and B is a column vector. A is 4 cross 3. B is a column vector. Therefore, augmented matrix AB is 4 cross 3 and additional column 4 cross 4 will come. Then a solution for every B, no solution for B, solution only when B equal to 0, a solution if B and columns of A are linearly, a solution if B and columns of A forms an independent set. See, it is not sum of values of lambda. If it is sum of values of lambda, we can write directly trace, na? We need not to solve the problem because matrix is known. It is not sum of lambda. It is sum of absolute values of absolute eigenvalues. Yeah, in this problem, it has no solution for some B is correct because maximum possible rank of A is 3, rank of AB could be 4 because you have 4 rows and 4 columns. It has no solution for some B is correct. Because matrix A is 4 cross 3. So maximum possible rank of A is 3. But in the case of AB, there is a possibility of rank 4. That's why rank of A not equal to rank of AB is possible for some B. Next. The eigenvalues of matrix A, 0, minus 1, 1, 0. 0, minus 1, 1, 0. See here. Lambda square plus 1 equal to 0. Lambda equal to plus or minus I. Lambda is equal to I comma minus I. Next problem. They have provided matrix A and a lower triangular matrix L. Our job is to calculate L32. It is a problem designed on LU factorization method. LU factorization method means the given matrix A, you have to write product of a lower triangular matrix and an upper triangular matrix. In this problem, matrix A is provided. Matrix L is also provided. The matrix U, you have to assume. Observe, matrix A is 25, 5, 4, 10, 8, 16, 8, 10, 22. The lower triangular matrix L is 1, 0, 0, L2, 1, 1, 0, L3, 1, L3, 2, 1. Now, upper triangular matrix U11, U12, U13, 0, U21, U22, U23. 0, 0, U33. Multiply row with column U11. Second row with first column L21 U11. Third row with first column L31 U11. Next, first row with second column U12. Second row with second column L21 U12 plus U22. Third row with second column L31 U12, L32 U22. Next, first row with third column U13. Second row with third column L21 U13 plus U23. Third row with third column L31 U13 plus L32 U23 plus U33. Equate corresponding elements on both sides. U11 equal to 25. U12 equal to 5. U13 equal to 4. Now L21 U11 is 10. L21 equal to 10 by 25. L21 equal to 2 by 5. L21 is 2 by 5. L31 U11 equal to 8. L31 equal to 8 by 25. Okay na? Next, L21 U12. L21 U12 plus U22 equal to 8. L21 is 10 by 25. U12 is 5. 8 minus 10 by 5, 5 5 ja 5 2 ja 2. That is 6. U22 is 6. Next, L21 U13. L21 U13 plus U23 equal to 16. Now L21 is 2 by 5. U13 is 4. U23 is 8 by 5. 72 by 5. U23 is 72 by 5. What is our job? Our job is to calculate L32. L32 means now L31 U12. L31 U12 plus L32 U22. L31 U12 plus L32 U22 equal to 10. Now substitute the values. L31 is 8 by 25. U12 is 5. L32 is unknown. U22 is 6. Equal to 10. 6 into L32 equal to 10 minus 8 by 5. 50 minus 8, 42 by 5. L32 equal to 7 by 5. That is 1.4. L32 is 1.4. L32 is 1.4. Next, one of the eigenvalues of a 3 cross 3 matrix M is 3. One of the eigenvalue of a 3 cross 3 matrix M is 3. If determinant value of M is 24, trace of M is 9, then the smallest eigenvalue of M inverse, Then the smallest eigenvalue of M inverse. Observe, matrix is 3 cross 3. Determinant value of M is 24. Trace of M is 9. Determinant value of M is 24 means lambda 1 into lambda 2 into lambda 3 is 24. Lambda 1 plus lambda 2 plus lambda 3 equal to 9. In the data it is given that one of the eigenvalue is 3. One of the eigenvalue is 3. Therefore, lambda 1 into lambda 2 into 3 equal to 24. Lambda 1 plus lambda 2 plus 3 equal to 9. Lambda 1 into lambda 2 is 8. Called it 1. Lambda 1 plus lambda 2 equal to 6. Called it 2. From 1 and 2, one eigenvalue 2, another eigenvalue 4. Anyhow, third eigenvalue 3. Eigenvalues of M are 2, 3, 4. Now eigenvalues of M inverse are 1 by 2, 1 by 3, 1 by 4. Therefore, smallest eigenvalue of M inverse is 1 by 4. Smallest eigenvalue of M inverse is 1 by 4. Next problem. Let M be a 3 cross 3 matrix. The maximum number of linearly independent eigenvectors. The maximum number of linearly independent eigenvectors. Observe, first you have to calculate eigenvalues. One minus lambda 1 1 0 1 minus lambda 1 0 0 1 minus lambda. Lambda equal to 1 comma 1 comma 1. So algebraic multiplicity of eigenvalue 1 is 3. Because same eigenvalue repeated 3 times. Now our job is to calculate geometric multiplicity. That's why consider M minus 1i of x equal to 0, 0, 1, 1, 0, 0, 1, 0, 0, 0. rank of m minus I is 2. Number of variables equal to 3. Geometric multiplicity is total number of variables minus rank of m minus I. That is 1. Therefore, one and only one independent eigenvector. Therefore, one and only one independent eigenvector is the correct option. Next problem. It is concept based question. Let Ax equal to B. Ax equal to B is a system of m linear equations in n unknowns with m less than n and b not equal to 0. Then the system has geometric multiplicity equal to number of linearly independent eigenvectors. Geometric multiplicity always gives you number of independent eigenvectors. If you have any doubt, I will write, no problem. Observe. The equations are x2 plus x3 equal to 0, x3 equal to 0. From 1 and 2. x2 0, x3 0. One variable is free variable. Let us take x1 is k. Therefore, x1, x2, x3 is k0, 0. K times of 1, 0, 0. Dvivedi. That's why you got only one independent eigenvector. Because geometric multiplicity is 1. Understood? It is concept based question. Sir, it is a non-homogeneous system with m less than n. Then the system has 100%. In the problem it is mentioned that Ax equal to B is the system of m equations with n unknowns and m less than n and b not equal to 0. Then the system has maximum possible rank of A is m. Okay, total number of variables are n. Therefore, n minus m free variables, n minus m solutions. It is also a concept based question. It is a problem designed on diagonalization. It was a previous XC question. Concept based question. Simple. Q and P are similar. Sir, how do you know that? Based on this, we can understand. Q and P are similar. Therefore, eigenvalues of P and eigenvalues of Q are same. Given that Q equal to R inverse PR, therefore Q and P are similar matrices. Okay na? If X is eigenvector of matrix P, then Y is equal to, because R inverse PR equal to Q na, therefore Y equal to R inverse X. Okay na? If X is eigenvector of P, Y is R inverse X is eigenvector of matrix PU, matrix Q. Okay na? Observe here, Px equal to lambda x can be written as Px equal to lambda x. Therefore, R inverse Px equal to R inverse lambda x. When you multiply lambda with R inverse either from left or from right, result is same na. So lambda into R inverse x, called it equation 2. R inverse Px equal to R inverse Pix. R inverse P, I can be written as R into R inverse X. That is R inverse PR, R inverse PR equal to Q na. QR inverse X, called it, R inverse Px equal to QR inverse X, called it equation 3. From 2 and 3, this is R inverse Px. R inverse Px equal to lambda R inverse X. R inverse Px equal to QR inverse X. Therefore, from 2 and 3, the conclusion is QR inverse X equal to lambda R inverse X. By this, I have given one conclusion. What is the conclusion? R inverse X is eigenvector of Q. Here I have written R inverse X is eigenvector of Q. How I have written R inverse X equal to eigenvector of Q? I found that Q into R inverse X equal to lambda into R inverse X. Therefore, R inverse X is eigenvector of Q corresponding to eigenvalue lambda, corresponding to eigenvalue lambda. Understood? R inverse X is eigenvector of Q. R inverse X is eigenvector of Q corresponding to eigenvalue lambda is the correct option. Last option is correct. It is concept based question. Next, let's MB, a 2 cross 2 matrix with eigenvalues 1 and 2. Then M inverse is. First you have to write characteristic equation. Lambda minus 1 into lambda minus 2 equal to 0. Lambda square minus 3 lambda plus 2 equal to 0 by Hamilton theorem m square minus 3m plus 2i equal to 0, 2i equal to 3m minus m square multiply with m inverse two into m inverse. M into m inverse is I, 3i. M square into m inverse is m. M inverse is 1 by 2 of 3i minus m. 3i minus m by 2. M inverse is 3i minus m by 2. Next problem. The number of n cross n matrices that are simultaneously Hermitian, unitary and diagonal. The number of n cross n matrices that are simultaneously Hermitian, unitary and diagonal. Observe. Hermitian means eigenvalues are real. Unitary means, unitary matrix means eigenvalues are of unit modulus. Means magnitude of each eigenvalue 1. Mod lambda equal to 1. Magnitude of lambda is 1. Length of each eigenvalue must be 1. In the case of diagonal matrix, when we will say matrix is diagonal matrix, all of diagonal entries are 0. All of diagonal entries are 0. Not only that, eigenvalues are its leading diagonal elements. Eigenvalues are its leading diagonal elements. Eigenvalues are its leading diagonal elements. Okay na? Now observe. N cross n matrix. Okay. It is a diagonal matrix. Remaining all entries are 0. Okay na? Next one. Eigenvalues of this diagonal matrix are nothing but A11th element, A22th element and ANnth element. Okay na? Now, sir, what are these elements? those elements are eigenvalues of Hermitian as well as unitary. For unitary matrix, eigenvalues have absolute value 1. For Hermitian matrix, eigenvalues are real. A real eigenvalues with magnitude 1 means either 1 or minus 1. That's why in the place of A11, you will have either 1 or minus 1. So 2 ways you can fill. This blank, 2 ways you can fill. This blank, 2 ways you can fill. So total number of different matrices are 2 into 2 into 2. How many times? N times. Therefore 2 power n. So correct answer is 2 power n. Understood? Next. Matrix M is 1BA, 1BA and 02C, 001, where ABC are real numbers. Then matrix M is diagonalizable for all values of ABC, or only when BC not equal to A, or only when B plus C equal to A, or only when BC equal to A. Understood? Now try this one. One BA, 02C, 001. Okay na? Now it is a triangular matrix, therefore eigenvalues of M are 1, 1, 2. Please observe this problem carefully. 2 is a different eigenvalue. Algebraic multiplicity of eigenvalue 2 is 1. Geometric multiplicity of eigenvalue 2 is also 1. Sir, without finding geometric multiplicity, how you have written here? Because 2 is a different eigenvalue. For every different eigenvalue, there will be one different independent eigenvector. That's why corresponding to eigenvalue 2, there exists one independent eigenvector. That's why geometric multiplicity of eigenvalue 2 is 1. AM and GM of eigenvalue 2 coincides. Now, sir, what about eigenvalue 1? In the case of eigenvalue 1, algebraic multiplicity is 2. Geometric multiplicity of eigenvalue 1, I am going to find out. That's why I am considering m minus lambda I. Substitute lambda equal to 1. One minus 1, 0. Two minus 1 is 1, 0, 1 C. 0, 0, 0. Next, you apply the operation. b times of r2 minus r1. Geometric multiplicity of eigenvalue 1 I am going to find out. Okay, b times of r2 minus r1 you'll get 0 minus 0, b minus b 0, bc minus a 0 0 0. Observe. What is your problem? The matrix is diagonalizable. Sir, when it is diagonalizable? When geometric multiplicity of eigenvalue 1 is 2, then it is diagonalizable. When geometric multiplicity of eigenvalue 1 will be 2, gm of 1 will be 2 only when rank of this matrix is 1. Rank of this matrix will be 1 only when bc minus a equal to 0. That's why I am writing. Geometric multiplicity of eigenvalue 1 will be 2. Will be 2 only when rank of m minus 1i, rank of m minus 1i is 1. It is possible only when bc minus a equal to 0. Therefore, a equal to bc compulsory, sorry, Divivedi, a not equal to bc hai to rank of m minus lambda I will be 2. Geometric multiplicity will be 1. Then it is not diagonalizable. It is diagonalizable only when geometric multiplicity is 2. Geometric multiplicity will be 2 only when rank of this matrix is 1. Rank of this matrix will be 1 only when bc minus a equal to 0. If bc minus a equal to 0, then rank of m minus lambda I will be 1. If rank of m minus 1 lambda I is 1, then geometric multiplicity will be 2. If geometric multiplicity is 2, then the matrix is diagonalizable. That's why a must be equal to bc. That's why correct answer is only when a equal to bc. It is diagonalizable only when a equal to bc. Got the logic? Yeah, excellent problem. Next. Let L is sin square 2x by x minus pi by 2 whole square when x tends to pi by 2. Sin square 2x by x minus pi by 2 whole square. when x is tending to pi by 2, numerator is tending to 0, denominator is also tending to 0. That's why apply El Hospital rule. That is sin 4x by x minus pi by 2. It is again 0 by 0 form. 0 by 0 form. Apply El Hospital rule. Limit x tends to pi by 2. Differentiation of sin 4x is 4 cos 4x by differentiation of x minus pi by 2 is 1. That is 4 cos 2 pi. That is 4. Final answer is 4. The maximum value of the function 2x plus 3y plus 4z on the ellipsoid 2x square plus 3y square plus 4z square equal to 1. So it is Lagrangian method. Let us take f is 2x plus 3y plus 4z. G is 2x square plus 3y square plus 4z square minus 1. The Lagrangian function f is f plus lambda g. Now, when you equate del f by del x to 0, two plus 4 lambda x equal to 0, that implies 4 lambda x equal to minus 2, lambda equal to minus 1 by 2x. Del f by del y to 0, 3 plus 6 lambda y equal to 0, that implies lambda equal to minus 1 by 2y. Del f by del z equal to 0 implies 4 plus lambda into 8z equal to 0. That implies lambda equal to minus 1 by 2z. This is called let us say this is 1, 2, 3, 4. From 2, 3, 4 you can write lambda equal to minus 1 by 2x equal to minus 1 by 2y equal to minus 1 by 2z. Therefore, x equal to y equal to z. Substituting x equal to y equal to z in G. Two x square. 3y square become 3x square. 4z square become 4x square equal to 1. Okay na? 2x square plus 3x square plus 4x square equal to 1. Therefore 9x square equal to 1. Therefore x square equal to 1 by 9. Therefore x is 1 by 3. Actually plus or minus 1 by 3. But I am taking 1 by 3 because our function is in square format. Okay na? So x is y is z means if x is 1 by 3, x equal to y equal to z means y equal to 1 by 3, z equal to 1 by 3. So 1 by 3 plus, yeah, x value 1 by 3, y value 1 by 3, z value 1 by 3. Therefore the function f is that is 2x plus 3y plus 4z na? 2 into 1 by 3, 3y, 3 into 1 by 3 plus 4z, 4 into 1 by 3. Finally, 2 plus 3 plus 4, 9 by 3. Final answer is 3. Next problem. Integral 0 to x square sine root t dt. Integral 0 to x square sine of root t dt. Then f dash of pi by 2 is. Integral 1 to x square sine root t dt. Therefore, sine of root x square into 2x. Sine root 1 into differentiation of 1, 0. Finally, f dash x is 2x into sine root x square. Now f dash of pi by 2 is 2 into pi by 2 sine square root of pi square by 4, that is pi by 2. That is pi. Finally, f dash of pi by 2 is pi. F dash of pi by 2 is pi. Let f of x is sin x by x when x not equal to 0, which is 1 when x equal to 0. Which one is correct option? F of x is sin x by x if x not equal to 0, which is 1 when x equal to 0. Now, I am calculating f dash of 0. F of x minus f of 0 by x minus 0. Sin x by x minus 1 by x minus 0. Sin x minus x by x square. When x is tending to 0, numerator is tending to 0, denominator is also tending to 0. Okay na? That is differentiation of x square is 2x, differentiation of sin x is cos x, differentiation of x is 1. Cos x minus 1 by 2x. Again it is 0 by 0 form. Apply L'Hospital rule. F dash of 0 is differentiation of cos x minus 1 is minus sin x. Differentiation of 2x is 2. When x is tending to 0, numerator is 0, 0 by 2 is 0. F dash of 0 is 0. Finally, the function is differentiable and f dash of 0 is 0. F dash of 0 is 0. The integral minus 1 to 1 x power minus 4 by 3 dx x power minus 4 by 3 dx x power minus 4 by 3 plus 1 by minus 1 to 1 minus 3 of 1 by x power 1 by 3 from minus 1 to 1 minus 3 of 1 by 1 power 3 is 1 minus 1 by minus 1 whole power 1 by 3, that is minus 1 whole power 1 by 3 is minus 1, minus 1 by minus 1 is plus 1, that is minus 6. Final answer is minus 6. Yeah, it is not an improper integral. Improper integral means it is tending to infinite. So it is not an improper integral, but whose value is equal to minus 6. Yeah. Next. The integral minus 5 pi by 2 to plus 5 pi by 2 f of x dx. F of x e power pi x square sin x cube four cos x dx. This is odd function, even function. Since it is odd function, therefore this value 0. Integral cos x is sin x from 0 to 5 pi by 2, that is sin 5 pi by 2 is 1, sin 0 is 0. Final answer is 8. Final answer is 8. Next problem. The function f of x is defined by 3 minus x square till x less than or equal to 1. 3 minus x in the interval 1 to 2 and x minus 1 when x greater than 2. So we have to solve this problem by using graph. You have to draw the graph. Three minus x square. 3 minus x square equal to 0, x square equal to 3, so x equal to root 3. So minus root 3 to plus root 3. Okay, 1 minute. One, two, three. Okay. Next. Because if you take this is 1, that is 3. 0, 1, 2. It is root 3, 1.7 something. From 1 to 2, it is 3 minus x. So straight line. From 2 to 3, again it is a straight line. X minus 1. Therefore, it has minima at 2. because slope changes from negative to positive at x equal to 2. Therefore, minima at x equal to 2, maxima at x equal to 0. Minima at x equal to 2, maxima at x equal to 0 is the correct answer. Maxima at x equal to 0, minima at x equal to 2. Maxima at x equal to 0, minima at x equal to 2. Just by observing the graph, you can able to find out. Here, curve is below the tangent. That's why here you have maxima. Here you have minima. The Taylor series expansion of f of x equal to 1 by 1 minus x about x equal to 0 is given as 1 plus x square plus x cube plus and so on. The series can be used to evaluate f of x for which one? Observe. F of x is 1 by 1 minus x. It is nothing but 1 minus x ka whole inverse 1 plus x square plus x cube plus and so on is valid only when mod x less than 1. That's why correct answer is mod x less than 1. So they have questioned what is domain for this. That is mod x less than 1. Observe. F of uv equal to u log v. Capital F is function of uv. U is x by y, v is minus x minus y. Then del f by del y. So here you have to understand one point. F is function of u and v. U and v are functions of x and y. V is function of x and v is function of y. Our job is to calculate del f by del y. That is given by del f by del u del u by del y plus del f by del v into del v by del y. F with respect to u with respect to y, f with respect to v and v with respect to y. To get f with respect to y. What is f with respect to u? Del f by del u is f with respect to u. Sir, f is u log v. When you differentiate with respect to u, you will get log v. U with respect to y, u is x by y. When you differentiate with respect to y, you will get minus x by y square. F with respect to v, u by v. V with respect to y, minus 1. Understood? Minus x by y square log v minus u by v. minus x by y square log v minus u by v. Second option is correct. Understood? Observe next problem. F of x is x sin x. G of x is mod x into sin x. Then if f of x is x sin x and g of x is mod x into sin x, then simple, f of x is x sin x. G of x is mod x sin x means minus x sin x when x less than 0 plus x sin x when x greater than 0. You have to understand like this. That is the meaning. Therefore, g dash x is minus x cos x minus sin x when x less than 0. X cos x plus sin x when x greater than 0. Observe, at x equal to 0, left hand derivative is 0, right hand derivative is also 0. Therefore, left hand derivative equal to right hand derivative. Therefore, we can conclude that g of x is differentiable at x equal to 0 is the correct option. G of x is differentiable at x equal to 0 is the correct option. Understood? Anyhow, f is differentiable, you need not check, because x is algebraic function, it is always differentiable. Sin x is differentiable. Product of two differentiable functions is always differentiable. It is not visible. This is okay. The value of integral 0 to 1 1 by square root of minus log t integral 0 to 1 by square root of minus log t when t is 0, x is infinite. When t is 1, x is 0. Integral infinite to 0, 1 by root x minus e power minus x dx. x power 1 by 2 minus 1 dx. Okay na? It is gamma function. Gamma half. Gamma half is root pi. Gamma half is root pi. Next problem. Integral 0 to 1 x square to x by y e power minus x square by y dy dx. Integral 0 to 1 x square to x by y e power minus x square by y dy dx. It is a problem designed on change the order of integration. Observe. One is y equal to x square. Another one is y equal to x. They have given lower limit x square, upper limit x. Lower limit x square, upper limit x. That means they have considered vertical strip. Between x equal to 0 and x equal to 1. Now, compulsory we have to change order of integration. To change the order of integration, you have to consider horizontal strip. Whenever you take horizontal strip, you have to write limits in terms of y. X equal to something. X equal to y is lower limit. X equal to root y is upper limit. Y equal to 0 to y equal to 1. Okay na? Then our integral become double integral x by y e power minus x square by y dx dy. X varies from y to root y. Y varies from 0 to 1. First we have to integrate with respect to x. That's why let us take x square by y is t. When x is y, t is also y. When x is root y, t is 1. 2x by y dx equal to dt. X by y dx equal to dt e power minus t. Now our double integral becomes y varies from 0 to 1, t varies from y to 1, e power minus t dt, then dy. Because x by y dx is dt, e power minus t dt, y to root y will become y to 1. Now integrate. Integral 0 to 1. Integral e power minus t is e power minus t by minus 1 from y to 1 dy. E power minus 1 by minus 1 minus e power minus y by minus 1 dy. One by minus 1 of 1 by e, that is y by e. E power minus y by minus 1 0 to 1. That is 1 by e minus e power minus 1 by minus 1, that is plus 1 by e minus 0. E power 0 is 1, 1 by minus 1, that is minus 1 of 2 by e minus 1, that is 1 minus 2 by e, that is e minus 2 by e. 1 minute. Before that you have 2 is there. X by y dx is 2 dt. The 2 is carry. 2 is carry. E minus 2 by, think 1 minute. It is 2 dt na. So it will become 1 minus 1 by 2. You have x by y dx. X by y dx equal to dt by 2. 1 by 2 dt. that is 1 by 2 of 1 minus 2 by e, 1 by 2e of e minus 2, e minus 2 by 2e. That is the correct answer. Got it? Next problem. Let the function f from 0 comma 5 to r, that means domain is 0 comma 5. How many then the number of points where f is not differentiable in the interval 0 comma 5, at how many points it is not differentiable? Observe here. The function f is 2x plus 5 in the interval 0 less than or equal to x less than 1. Next, two x square plus 5, 1 less than x less than 2, that is 2 by 3 into x cube plus 23 by 3, 2 less than or equal to x less than or equal to 5. Observe here f dash x. Calculate f dash x. In the interval 0 less than or equal to x less than 1, which is 4x. In the interval 1 less than or equal to x less than or equal to 2. Now 6x square plus 3 in the interval 2 less than or equal to x less than or equal to 5. Okay, na? Now at x equal to 1, you have to check at the point of 1 and 2, because left side of 1 function is 2x plus y, right side of 1 function is 2x square plus y. That's why I am examining at 1 whether it is differentiable or not. Left side of 1 at x equal to 1, left hand derivative is 2, but the right hand derivative is 4. Yes, left hand derivative not equal to right hand derivative. Therefore, f of x is not differentiable at x equal to 1. Next, verify at x equal to 2. At x equal to 2, left hand derivative is 4 to the 8. Right hand derivative is 2 square is 4, 4, 6 are 24, 24 by 3, 8. LHD equal to RHD. Left hand derivative equal to right hand derivative. Therefore, it is differentiable. The function is derivable at x equal to 2. Therefore, at one point x equal to 1, The function is not differentiable. The function is not derivable. In the interval 0, 5. At one and only one point, the function is not derivable. Next. The function, not function, f dash of x equal to f dash of x equal to 8 by x square plus 3x plus 4. What about the interval? Interval is, they have given f of 0 and f of 1. That means in the interval 0, 1 we have to examine. Therefore, the conclusion is, observe, f dash of 0 is greater than f dash of c, greater than f dash of 1. For c belongs to 0, 1. Verify. F dash of 0 is 8 by 4, 2, greater than f dash c, greater than f dash of 1 is 8 by 8, 1. Okay na? So 2 greater than f dash c greater than 1 by Lagrange's mean value theorem. 2 greater than f of 1 minus f of 0 by 1 minus 0 greater than 1. 2 greater than f of 1 minus f of 0 greater than 1. Okay na? Given that f of 0 is 1, so 3 greater than f of 1 greater than 2. Therefore, f of 1 value lies in the interval 2, 3. F of 1 value lies in the interval 2, 3. Yeah, 2 and 3 is the correct option. The perimeter of the rectangle having largest area that can be inscribed in an ellipse x square by 8 plus y square by 32 equal to 1 is the perimeter of the rectangle having largest area that can be inscribed in an ellipse x square by 8 plus y square by 32 equal to 1. Now Generally, all the vertices of the rectangle are lies on the ellipse. That's why it is first quadrant. General equation of the ellipse is x square by a square plus y square by b square equal to 1. That's why a cos theta and b sin theta is a general point on the ellipse. Here, third quadrant, minus a cos theta minus b sin theta. Here, second quadrant, minus a cos theta b sin theta. A cos theta minus b sin theta. Now, length of the rectangle is 2a cos theta. Breadth of the rectangle is 2b sin theta. Actually, in the problem, they have given x square by 8. Y square by 32 equal to 1. That's why x square by 2 root 2 whole square plus y square by 4 root 2 whole square equal to 1. Therefore, a value 2 root 2, b value 4 root 2. Now, in the problem it is given that the rectangle having largest area is maximum. What is area of the rectangle? Length into breadth. 2a cos theta into 2b sin theta. That is nothing but 2ab sin 2 theta. 2ab sin 2 theta. Understood? Area will be maximum when sin 2 theta equal to 1. Therefore, 2 theta equal to pi by 2. Therefore, theta is pi by 4. So, when theta equal to pi by 4, area will be maximum. Now, the perimeter is given by 2 into L plus B, 2 into 2a cos theta plus 2b sin theta, 2 times of a value 2 root 2, 2 into 2 root 2 plus 2 into 4 root 2, that is 2 times of 4 root 2 into 1 by root 2 plus 8 root 2 1 by root 2, root 2 root 2 cancel, 8 plus 4 is 12, 12 2 ja 24. Finally, the perimeter of the rectangle is 24. The value of x, where the function f of x equal to sin x plus cos x, f of x equal to sin x plus cos x in the interval 0 comma 2 pi attains minima, attains minima, attains minima. Now observe f dash x is differentiation of sin x is cos x. Differentiation of cos x is minus sin x. Equate f dash x to 0. X equal to pi by 4. 5 pi by 4. Both lies in the interval 0 comma 2 pi. Now f double dash of x is differentiation of cos x is minus sin x. Differentiation of sin x is cos x. Right? F double dash of pi by 4 minus root 2. F double dash of 5 pi by 4 minus of minus 1 by root, that is root 2. This is negative. This is positive. Therefore, here it attains maxima. Here it attains minima. The problem is designed on minima. The problem is designed on minima. The function attains minima at x equal to 5 pi by 4. The function attains minima at x equal to 5 pi by 4. That is nothing but 5 pi by 4 is nothing but 3.925. That is the answer. Understand? Prajapati, in XC, mathematics part is difficult than all other branches. Okay, na? You have to practice well. The value of the following limit x tends to infinite, x minus sin x by x plus sin x plus log x by x. X minus sin x by x plus sin x plus log x by x. No problem. Now if you take x common, you'll get 1 minus sin x by x plus 1 plus sin x by x. Limit x tends to infinite, log x by x. This is 1 plus 0 by 1 minus 0 plus, when x is tending to infinite, numerator is tending to infinite, 1 by x by 1. You'll get 1 plus 0. Final answer is 1. Final answer is 1. The volume of the solid obtained by revolving the curve x equal to y square in the interval 0 to 1 around y axis is x equal to y square around y axis. Like this. Now, volume of revolution is integral minus 1 to 1, generally C to D, pi x square dy. X is y square na, x square is y power 4 dy. 2 times of 0 to 1 pi into y power 4 dy. 2 pi into y power 5 by 5 0 to 1. That is 2 pi by 5. 2 pi by 5. But in the data, it is given that x varies from only 0 to 1. So you have to take half of the volume only. But I have taken x varies from minus 1 to 1. But you require only half of that. Given that zero less than or equal to x less than or equal to 1, therefore the required volume equal to 2 pi by 5 by 2. Finally it is pi by 5. Final answer is pi by 5. Prajapati, we cannot say like that, because in what depth they are going to design the paper, we don't know. That's why you cannot say that in this topic you'll get 6-7 marks. Examination paper is completely unpredictable. Only the thing is you have to cover entire syllabus. You have to prepare in a mode that the paper will be tough. Okay? If it is easy, you are lucky. Next problem. F of x is 2x cube minus 3x square plus 69. Interval is minus 5 comma 5. Interval is minus 5 comma 5. Okay na? First calculate f dash x. 6x square minus 6x. F double dash x is 12x minus 6. When you equate f dash x to 0, six x square minus 6x equal to 0. X equal to 0, x equal to 1. At x equal to 0, f double dash of 0 is minus 6. At x equal to 1, f double dash of 1 is plus 6. Now we have to calculate maximum value of f of x in the interval minus 5 comma 5. So it is absolute maxima. It attains maxima at 0. 0 is also lies in the interval minus 5 comma 5 na, that's why f of 0. Now maximum of functional value at minus 5, functional value at 5, functional value at 0. Functional value at minus 5 is minus 256. Functional value at 5 is 244. Functional value at 0 is 69. Among all these values, maximum value is 244. Therefore, the function attains global maxima at x equal to plus 5. It attains global maxima at x equal to 5, plus 5. Yeah, 244 is maximum value of the function. It attains global maxima at what value of x means x equal to 5. Integral 0 to pi by alpha, 0 to pi by alpha, sin y by y, dy dx is equal to 1 by 2. Then the value of alpha is, actually it is not 0 to alpha, it is x2. For alpha greater than or equal to 1, please observe. This is given data. Y equal to x, y equal to pi by alpha, x equal to 0, x equal to pi by alpha. Based on the given limits, I am identifying the region. Y equal to x. That is y equal to x. Y equal to pi by alpha, parallel to x-axis. In this region, this person has considered vertical strip. This is the region. In that region, we have to change the order. To change the order, I am going to consider horizontal strip. In the same region, I am going to consider horizontal strip. X equal to 0, x equal to y. Y equal to 0, y equal to pi by alpha na? Pi by alpha. Double integral. X varies from 0 to y. Sin y by y. Dx dy equal to 1 by 2. Now first integrate with respect to x. 0 to pi by alpha. Integral dx is x. 0 to y. Dy equal to 1 by 2. Now integral 0 to pi by alpha. Sin y by y. Y cancel. Integral sin y is minus cos y. 0 to pi by alpha equal to 1 by 2. Minus cos pi by alpha plus cos 0 equal to 1 by 2. Minus cos pi by alpha plus 1 equal to 1 by 2. Minus cos pi by alpha equal to uh, 1 by 2 minus 1 minus 1 by 2. Cos pi by alpha equal to 1 by 2. Observe. Sir, 1 by 2 is nothing but cos pi by 3. Therefore, pi by alpha equal to pi by 3. Therefore, alpha equal to 3. Like this. Because directly sin y by y with respect to y not integrable. That's why we have changed the order of integration. X sin x cos 1 by x when x not equal to 0. which is 0 when x equal to 0. G of x is x cos 1 by x when x not equal to 0, which is 0 when x equal to 0. Now do one thing, I am going to calculate f dash 0 as well as g dash 0. Based on that we can estimate. F dash of 0 is, limit x tends to 0, f of x minus f of 0 by x minus 0. F of x is x sin x into cos 1 by x minus 0 by x minus 0, that is x sin x into cos 1 by x sin x into cos 1 by x, which is 0. Now limit x tends to 0, g of x minus g of 0 by x minus 0, g of x is x cos 1 by x, g of 0 is 0 by x, cos 1 by x when x tends to 0, limit does not exist. So f dash of 0 exists, but g dash 0 does not exist. So f is differentiable, g is not differentiable. F is differentiable, g is not differentiable. Understood? Next, f of x is bx plus a. When x less than 1, 5x square when x greater than or equal to 1. If it is continuously differentiable, then a square b value. Do one thing. You require a value, b value, then a square b value. Now observe. F dash x is b when x less than 1, 10x when x greater than or equal to 1. Okay na? If the function is differentiable, definitely it is continuous. Therefore here b equal to 10. Here left hand derivative is b plus a, right hand derivative is 5, called it 1, called it 2. If b is 10, a is minus 5. From 1 and 2, a is minus 5, b is 10. Therefore a square b is a value minus 5, a square is minus 5 whole square into b, b is 10, 25 into 10, 250, a square b is 250. Understood? Very good. A is minus 5, b is 10. Next problem. A rectangular box without top cover having square base is to be made from a sheet of 108 square meters, then the largest possible volume of the box in cubic meters. Volume of the box is x square h. Why x square h? Square base na, that's why x into x. Height is h. Now surface area is 4 walls, 4xh. Open at the top na, that's why x square plus 4xh. Given that x square plus 4xh is 108, therefore 4xh is 108 minus x square, h is 108 minus x square by 4x. This is called equation 1. This is called equation 2. Substituting 2 in 1, we get volume V equal to x square into 108 minus x square by 4x. That is nothing but 27x minus x cube by 4. Calculate V dash. 27 minus 3x square by 4. V double dash minus 6x by 4. When you equate V dash to 0, you'll get 3x square by 4 equal to 27. 27 into 4 by 3, that is 36. X equal to 6. At x equal to 6, V double dash is minus 36 by 4 minus 9 negative maxima. So volume is maximum when x equal to 6. At x equal to 6, height is 108 minus x square by 4x. That is 72 by 24, that is 3. Yeah, dimensions are x is 6, height is 3. Therefore, volume is x square h, 36 into 3, 108. 108 cubic meters is the correct answer. Not 432, Mayank, 108 cubic meters, 108 cubic units. The number of critical points for the function f of xy is x cube plus 3xy square minus 15x minus 12y del f by del x is 3x square plus 3y square minus 15. Del f by del y is Del f by del y is 6xy minus 12. R is del square f by del x square. S is del square f by del x del y. T is del square f by del y square. Six x, 6y, that is 6x. When you equate del f by del x to 0, or del f by del x to 0, three x square plus 3y square equal to 15. X square plus y square equal to 5. 6xy minus 12 equal to 0. Xy equal to 2. Y equal to 2 by x. Substitute y equal to 2 by x here. X square plus 4 by x square equal to 5. That is x power 4 minus 5x square plus 4 equal to 0. From this we can write x square minus 1 into x square minus 4 equal to 0. X equal to plus or minus 1. X equal to plus or minus 2. X equal to plus or minus 1 and x equal to plus or minus 2. Now when x is 1, y is 2. When x is minus 1, y is minus 2. Because 2 by x. Okay, na? When x is 2, y is 1. When x is minus 2, y is minus 1. So now, at each and every point, I am going to examine r value, s value, t value. 1, 2, x is 1, y is 2. R value 6. T value 6. S value 6y. 6y 12. At every point I am going to check RT minus S square and R value. 36 minus 144. Okay na? 36 minus 144 minus 108. Negative. Neither min nor max. At 1, 2, neither min nor max. Next. Here R value 12, t value 12, 2y, that is 2. Yeah. Total 4 points we have. X is 2, y is 1. When x is 2, y is 1, 144 minus 4, 2y, y value 1 na? S value 2y, 6y, sorry, 6y, so this is 6. That is positive or positive, therefore minima. At 2 comma 1 minima, at 2 comma 1 minima. What about 6y? Next, minus 12. At x equal to minus 2, it is minus 12. X value 6y, minus 6. T value minus 12. Positive. 36 plus 8 na? 108 positive. And R value negative. Therefore maxima. At minus 2 comma minus 1 maxima. Okay na? Next, minus 1 comma minus 2. At minus 1 comma minus 2. R value 6x. S value 6y. T value 6x. RT minus S square. 36 minus 144 minus 108. Negative, neither min nor max. Understand? Neither min nor max. 1 minima, 1 maxima, 2 neither min nor maxima. The number of points. Function has minima where f of x is x square by 2 plus y power 4 by 4 minus y square by 2 minus y square by 2. Try this one. Del f by del x is two x by 2x. Del f by del y is y cube minus y, or del square f by del x square, that is 1. Del square f by del x del y 0. del square f by del y square, 3y square minus 1. When you equate del f by del x to 0 and del f by del y to 0, you'll get x equal to 0, y equal to 0, y equal to 1, y equal to minus 1. So one point is 0 comma 0. At 0 comma 0 r value, s value, t value. At 0 comma 0 r value 1, s value 0, t value 3y square minus 1. Finally minus 1. rt minus s square is minus 1. Negative. Neither min nor max. Neither minima nor maxima. Next point is 0 comma 1. R value 1, S value 0. T value 3y square minus 1. Here y value 1 3 minus 1 2. RT minus S square 2 positive. R value 1 positive. Therefore minima. Similarly, at 0 comma minus 1, R value 1, S value 0, T value 2. RT minus S square is positive. R value is also positive. Therefore minima. So how many minima you have? 2 minima. Finally 2 minima is the correct option. Observe this problem. Let u of xy is tan of xy plus xy of x plus y. U is not homogeneous function. Tan inverse U is homogeneous of degree 3. Actually it is tan inverse. You have to take tan on both sides. That will become tan U. Tan U is a homogeneous function of degree 3. Therefore x into del U by del x y into del U by del y equal to n into f of U by f dash U. N is degree. Function of U is tan U. Differentiation of tan U is secant square U. Understood? Now 3 into tan of tan UE is, directly you can write the function x square y or xy of x plus y by 1 by secant square u, 1 by secant square u. If tan u is like this, secant square u can be written as tan square u minus 1. Understood? So tan u by secant square u. Substitute u value, automatically we will get the answer. Next. Let C be the boundary of the square. Let C be the boundary of the square. 0 less than or equal to x less than or equal to 1, 0 less than or equal to y less than or equal to 1. Understood? It is a problem designed on Green's theorem. It is a problem designed on Green's theorem. X varies from 0 to 1, y varies from 0 to 1, it represents a square. Curve is a closed curve. When curve is closed curve, vector has two components. You can understand that. It is a problem on Green's theorem. Now F1. F1 is minus y. F2 is x. Del F1 by del y is minus 1. Del F2 by del x is 1. By Green's theorem, integral C F1 dx plus F2 dy equal to double integral R del F2 by del x minus del F1 by del y into dx dy 1 minus of minus 1 dx dy, that is 2 into double integral dx dy, 2 into area. Area is length into breadth, that is 1 into 1. Finally 2 is the answer. Next problem. U bar is minus wy I cap. It is minus. Please observe. Plus wx j cap. V is wz j cap minus wy k cap are two given vectors. W is constant, then divergence of u bar cross v bar. First you have to calculate u bar cross v bar. First you have to calculate u bar cross v bar. I bar of w square xy. This is minus na. Minus 0. Minus j bar of w square y minus 0 plus k bar of minus w square yz. Now divergence of u bar cross v bar del dot u bar cross v bar del by del x of minus w square xy del by del y of minus yw square del by del z of minus w square yz. When you differentiate with respect to x, minus w square y. When you differentiate with respect to y, minus w square. When you differentiate with respect to z, sorry, this is y square. Minus w square minus 2 w square y. Finally, minus 4 w square y is the answer. Finally, minus 4 w square y is the answer. They have given p bar and q bar. We have to check whether p bar is solenoidal or q bar is solenoidal, or p bar is irrotational or q bar is irrotational. Sorry, we have to check only solenoidal. Which of the following is solenoidal? Now first I am calculating del dot p bar. Del by del x of 2x square plus 8xy square plus z del by del y of 3x cube y minus 3xy del by del z of minus 4y square z square minus 2x cube z. Now del by del x of 2x square is 4x, 8xy square is 8y square, Del by del y of 3x square y is plus 3x square minus 3x minus 8y square z minus 2x cube. Now, if you verify del dot p bar is non-zero, 4x minus 3x is x, 8y square. Sorry, here z is there. It is 8y square z. So then 8y square z will come. So plus 8y square z minus 8y square z cancel. Anyhow, when you differentiate with respect to y, you will get 3x cube minus 3x. 3x cube minus 2x is x cube. 4x minus 3x is plus x. Anyhow, it is non-zero. So p bar is not solenoidal. P bar is not solenoidal. What about Q bar? Q bar is xyz square into P bar. Now del dot Q bar is del by del x of 2x cube yz square 8x square y cube z cube plus del by del y of 3x power 4 y square z square minus 3x square y square 3x square y square z square bracket close plus del by del z of minus 4x y cube z power 4 minus 2x power 4 y z cube. Differentiate. Now 6x square y z square plus 16x y cube z cube 16x y cube z cube plus 6x power 4 y z square minus 6y x square y z square y already written, so z square plus minus 16 xy cube z cube minus 6x power 4 y z square plus 6x power 4 y z square minus 6y x square z square cancel. This term and this term cancel. This term and this term cancel. Finally 0. So del dot q bar 0. Therefore q bar is solenoidal. P bar is not solenoidal, but Q bar is solenoidal. So last option is correct. Understood? Next column. Consider the function f at the point P. The value of f does not change due to the value of f does not change due to small displacement of P along the direction of. In what direction? It does not change. So grade F at point P dot, which vector does not change small displacement? Okay, na? So we have to calculate grade F at point P dot, the given vector. Okay, na? F is x cube into e power y sin z. Grade F I bar del f by del x plus j bar del f by del y plus k bar del f by del z grade F at 1 0 pi by 2 1 0 pi by 2 3 I bar plus j bar. Now first option. Three I bar plus j bar dot. In first option, I bar plus pi by 2 k bar. Gives us 3. Yeah, there is a change in the displacement 3. So this is not the answer. Next, second option. Three I bar plus j bar dot. 1 minus 1 means I bar minus j bar plus k bar. 3 minus 1, that is 2. Here also there is a small displacement. So this is not the answer. You have to get dot product must be 0. Grade F at point P dot B bar. 3 I bar plus j bar dot. You select the vector from the option. 1 minus 3 0. I bar minus 3 j bar. That is 3 minus 3 0. Here there is no change in the displacement. Therefore third option is correct. Fourth option. Grade F at point P dot B bar. 3 I bar plus j bar dot. Last option is 2 0 minus 1. After taking dot product, 6 plus 0, that is 6. There is a change in the displacement, that's why it is also incorrect. 0 only in the case of third option, that's why third option is correct. Now F is x power 4 minus 5xy square. Yeah, in what direction directional derivative increases? At the point 2 comma 2. So you have to calculate grade F at 2 comma 2. F is x power 4 minus 5xy square. Grade F I bar del f by del x plus j bar del f by del y write grade f at 2 comma 2. 2 cube is 8 4 ja 32. 5 into 4 20. 10xy. 10 4 ja 40. If you take 12 I bar minus 40 j bar. If you take 4 common, 4 times of 3I bar minus 10 j bar. In which direction it is maximum? 3I bar minus 10 j bar direction. 3I bar minus 10 j bar direction. Third option is correct. Understood? Next problem. E power x I cap plus 3y j cap minus z into e power x k cap, where S is the sphere. Apply Gauss divergence theorem. To implement Gauss divergence theorem, first you have to calculate del dot f bar. Del by del x of e power x, del by del y of 3y, del by del z of minus z e power x. E power x plus 3 minus e power x, finally 3. Double integral is f bar dot n cap ds is triple integral v divergence f bar dv 3 into volume 4/3 pi r cube 1 cube. 4 pi is the answer. Final answer is 4 pi. Understood? Next, the work done by force F bar of a moving particle along the triangle. Triangle is a closed curve, na? Whenever curve is closed curve, better to go for Gauss divergence theorem. Sorry, when curve is closed curve, look at the vector. Vector has 3 components or 2 components. Vector has 2 components. Therefore, Green's theorem. 0 0 1 0 0 1. Curve is closed curve. Region is bounded by closed curve. And vector has only 2 components. F1 is x plus x square. F2 is x square plus y cube. Okay na? Del F1 by del y. Del F2 by del x. 2x. Integral C. F1 dx plus F2 dy equal to double integral R. Del F2 by del x minus del F1 by del y into dx dy. 2x minus 0 into dx dy. You can take horizontal strip or vertical strip. If you take horizontal, you have to write x limits. X equal to 0, x equal to 1 minus y. Y equal to 0, y equal to 1. Integrate with respect to x. 2 into x square by 2 2 to cancel. 1 minus y whole square dy, 1 plus y square minus 2y dy, integral 1 dy is y, integral y square dy is y cube by 3, 2 into y square by 2 is y square, from 0 to 1, that is 1 plus 1 by 3 minus 1. Final answer is 1 by 3. Final answer is 1 by 3. If the work done of a moving particle around a circle under the force field is 16 pi, under the force field is 16 pi, if you have 3 components, then you have to apply Stokes theorem. Stokes theorem. Curve is closed curve. Vector has 3 components. Then Stokes theorem. Akshay. Here curve is closed curve. Here curve is closed curve. Vector has only 2 components. Therefore Green's. X square plus y square equal to 4. Circle. F1 is 2x minus ay. F2 is 2y plus ax. Del F1 by del y minus a. Del F2 by del x a. Now by Green's theorem, integral C F1 dx plus F2 dy equal to 16 pi, that is given in the data. Now double integral R del F2 by del x minus del F1 by del y into dx dy equal to 16 pi. Understood? 16 pi. Now continuation. Del F2 by del x is a minus del F1 by del y is minus a. That's why 2a dx dy equal to 16 pi. That is 2a into area of the circle pi r square equal to 16 pi. Therefore 4 pi into 2a, 8 pi a equal to 16 pi, a equal to 2. Finally mod a equal to 2 is the answer. Understood? Right. The divergence of a vector field v bar equal to 2x I bar plus 2, 2 power y j bar plus 2 power z k bar at the point 1 comma 1 comma 1. Very simple problem. Del dot v bar equal to del by del x of 2 power x plus del by del y of 2 power y plus del by del z of 2 power z. That is 2 power x log 2 plus 2 power y log 2 plus 2 power z log 2 at the point 1 comma 1 comma 1, 2 log 2 plus 2 log 2 plus 2 log 2, that is 6 log 2, that is log 2 power 6, that is log 2 power 5 is 32, 2 power 6 is 64, log 64. That is the answer. 4.1. Yeah, this is x square, y square, z square. Okay, na? Now, it is Gauss divergence theorem because it is a closed surface. Gauss divergence theorem means first we have to calculate divergence f bar. Del by del x of 4x plus del by del z of minus z. This is 4 minus 1, that is 3. By Gauss divergence theorem, double integral is f bar dot n cap ds is triple integral v 3 dv, 3 into volume, 3 into 4 third pi r cube, unit circle na 4 pi, final answer is 4 pi. Final answer is 4 pi. Integral C f bar dot dr bar, integral C to f bar dot dr bar. So we have to calculate f bar dot dr bar along C1 as well as along C2. Then C1 minus C2. You have to calculate. First, integral C1. xy bar. xy bar means xy dy will come. Along C1, x is t, y is t square. Dx is dt, dy is 2t dt. T varies from 0 to 1. X is t, y is t square, dy is 2t dt. Finally, 2 into t power 4 ka integration t power 5 by 5 from 0 to 1. That is 2 by 5. 0.4. Next. Integral C2 f bar dot dr bar. Integral C2 xy dy, where x is t. Y is root t. Dx is dt. Dy is 1 by 2 root t dt. T varies from 0 to 1. That is 0 to 1. X is t. Y is root t. Dy is 1 by 2 root t dt. 1 by 2 into t square by 2. 0 to 1. 1 by 4. 0.25. Therefore, integral C1 f bar dot dr bar minus integral C2 f bar dot dr bar is 0.4 minus 0.25. Finally 0.15. Finally 0.15. Understood? Next problem. It is a simple closed curve enclosing the region R. Then the value of integral. It is also a problem on Green's theorem. M is or F1 is y plus e power x square. F2 is 3x plus cos y. Del f1 by del y is 1. Del f2 by del x is 3. By Green's theorem, f1 dx plus f2 dy equal to double integral r del f2 by del x minus del f1 by del y into dx dy, that is 3 minus 1 dx dy, double integral 2 dx dy equal to 16. That is 2 into area of the closed region, area of the closed region, equal to 16. Therefore, finally, double integral r dx dy is 16 by 2, that is 8. 8 square units is the area of the region. Understood? Next problem. This is minus x of t is cos t. Y is sin t. Z is 2t square. Okay na? Now dx is minus sin t dt. Dy is cos t dt. Dz is 4t. T varies from 0 to 1. Okay na? Integral C f bar dot dr bar is integral C f bar dot dr bar is Atul Yadav. Stokes theorem is applicable only when your curve is closed curve. Here it is not closed curve. Did they mention? C is described by a parametric form. Okay na? You have to calculate only line integral. Integral C f bar dot dr bar is integral C f1 dx plus f2 dy plus f3 dz. You have to convert all the variables in terms of t. That is the logic. Minus y dx plus x dy plus z dz. Okay na? Now minus sin t into minus sin t dt plus x cos t into cos t dt plus z dz 2t square into 4t dt from 0 to 1, integral 0 to 1, sin square t plus cos square t plus 2 8t cube dt, that is 1 plus 8t cube dt, integral 1 dt is t, 8t cube is 8 to power 4 by 4, from 0 to 1, 1 plus 8 by 4, 8 by 4 is 2, finally 3. Final answer is 3. Understood? Next, 2 by pi minus y cube dx plus x cube dy, where the circle is x square plus y square equal to 1. Curve is closed curve, vector has two components, x equal to cos theta, y equal to sin theta, dx is minus sin theta d theta, dy is cos theta d theta. Theta varies from 0 to 2 pi. Understood? Now by Green's theorem, f1 is minus y cube, f2 is x cube, del f1 by del y minus 3y square, del f2 by del x 3x square. Now by Green's theorem, integral c f1 dx plus f2 dy equal to double integral r del f2 by del x minus del f1 by del y into dx dy, that is 3x square plus 3y square dx dy, that is 3 into x square plus y square dx dy. That's why I am writing 3 into r square into r dr d theta. Radius varies from 0 to 1. Theta varies from 0 to 2 pi. Okay na? Now integral 0 to 2 pi 3r cube, 3 into r power 4 by 4 from 0 to 1 d theta, that is 0 to 2 pi 3 by 4 into d theta. Understood? That is 3 by 4 into 2 pi, that is 3 pi by 2. Our job is to calculate 2 by pi of minus y cube dx plus x cube dy value. Sir, we have already calculated minus y cube dx plus x cube dy value, f1 dx plus f2 dy value. Okay na? 2 by pi of 3 pi by 2. Final answer is 3. Final answer is 3. Our job is to calculate if curl V bar is 0, then what is for what condition? Curl V bar is 0. Equate curl V bar to 0. del by del x, del by del y, del by del z, ax minus bz plus cy I bar of del by del y of cyc plus b minus j bar of 0 minus 0 plus k bar of 0 minus 0 equal to 0. Therefore, c plus b equal to 0, b equal to minus c, or c equal to minus b. B equal to minus c is the correct answer. Minus z dx plus x dy plus y dz, where c is obtained by the intersection of x square plus y square equal to a square and y equal to z. In the place of y you had to write z. Okay na? Now observe. Minus z dx plus x dy plus y dz plus y dz integral c. Since z is y, that's why y dx plus x dy plus y dy, that is integral 0 to 2 pi, because circle is x square plus y square equal to a square na, that's why x equal to a cos theta, dx equal to minus a sin theta d theta, y equal to a sin theta, dy equal to a cos theta d theta. Substitute now. Minus a sin theta minus a sin theta d theta plus a cos theta dy a cos theta d theta plus y a sin theta into a cos theta d theta. Simplify this. That is integral 0 to 2 pi a square sin square theta plus a square cos square theta a square plus a square sin theta cos theta d theta, that is 0 to 2 pi, take a square common, 1 plus sin 2 theta by 2 d theta, a square into 0 to 2 pi 1 d theta integral 0 to 2 pi sin 2 theta by 2 d theta, that is a square into 2 pi plus 0. Final answer is 2 pi a square. Final answer is 2 pi a square. Understood? Next problem. It is curve circle. Curve is closed curve. Vector has two components. That's why Green's theorem. Now F1 is xy square plus 2x. F2 is x square y plus 4x. Del F1 by del y 2xy, del f2 by del x, 2xy plus 4 by Green's theorem, integral C f1 dx plus f2 dy equal to double integral r del f2 by del x minus del f1 by del y into dx dy, that is 2xy plus 4 minus 2xy dx dy, 2xy cancel, 4 into double integral dx dy, 4 into area of x square plus y square equal to 4, pi r square, pi into 2 square, 4 pi into 4, 16 pi. Final answer is 16 pi. I hope you understand. Tomorrow again we have a class at 8 p.m. 8 a.m. We will meet tomorrow morning at 8 a.m. Thank you.